In this chapter, we're going to talk about the basic building blocks of a Java program, and that's data and data types. This particular lesson will provide an introduction to data types and a reason for why we need to use data types in our programs. First of all, a data type defines the proper use of an identifier or an expression. An identifier can include things like a variable name or a function, and an expression could be an arithmetic expression, such as a formula, or a string expression where we add text together using something called concatenation. By making sure that our data is well defined, then we make sure that we're using the identifiers and expressions in a correct way. This will actually become more clear as we go through this lesson. Data types also help us determine what type of data can be stored in an identifier or written in an expression. So for example, when we have numeric identifiers like numeric variables, then only numbers can be stored in those variables. Same thing with strings. If we have a string variable, then only a string can be stored in that variable. When we write an expression such as 2 plus 2, the fact that we're using two numeric pieces of data with a arithmetic operator, the plus sign, indicates that that's a legal numeric expression. Just like if we wrote an expression where we wrote hello plus world, which were strings, then that would be legal because the plus sign signifies concatenation for strings. Data types also help us decide what types of operations can be performed on an identifier or an expression. So for example, with a numeric data type, we can perform the standard arithmetic operations. Just like with strings, Java has a set of operations that are defined that can be performed on strings, but not on other types of data. An example of a legal numeric expression is 12 plus 2. Here we have two numeric pieces of data, 12 and 2, actually integers, and the plus sign, which indicates we want to add 2 to 12, and that's legal. An example of an illegal numeric expression might be 12 plus Mike. Here we have a numeric piece of data, 12, and string data, Mike, and those cannot be added together legally. An example of a legal string expression might be hello plus world, where we want to concatenate world to hello to get the single phrase, hello world. And then finally, an example of a legal arithmetic expression is salary times tax rate, where salary and tax rate are defined as numeric variables which can be multiplied together. Some examples of legal numeric data include 1,000, which is an integer, and 3.14159, which is a floating point value, or in Java terms, a double. We have string data such as hello world and Mike. String data is any data that is surrounded in double quotes. Java also has character data, which are single characters surrounded in single quote marks. That data type is called char, and we'll look at it in more detail later. And then finally, we have the Boolean data type, and that's for true and false values. We use Boolean data when we're trying to make decisions in code, either in a branching situation where we decide if we want to perform one set of instructions or another set of instructions, or perhaps in a looping situation where we need to determine if we want to continue looping over a set of code based on some relational expression. And we'll look at all those in more detail later. So that's a brief introduction to data types. In my next lesson, we're going to look specifically at the numeric data types found in Java. There are two main categories of numeric data types in Java: the integral data types and the floating point data types. We're going to begin by discussing the integral data types. The two main integral data types are int for integer and long for long integer. The int data type stores numbers in the range of negative 2,147,483,648 to positive 2,147,483,647. In general, that is enough storage for any integer value that you're going to work with, and certainly in this course, that's plenty of room. However, if you don't have enough room, you have the possibility of using the long data type. And I'll just let you look at the range that the long stores. Those numbers are quite large. In the floating point types, and here we're talking about numbers with fractional parts, such as pi, 3.141569, or some other value like that, we have two data types, float and double. The float data type allows you to store up to 127 digits after the decimal point, and the double allows you to store 1023 digits after the decimal point. However, we will always use the double for the floating point data type in Java. That's just the standard as opposed to using the float. After the two main integral and floating point data types, we have two or three other less important integral types that we want to at least mention in this lesson. There's the byte, which can store small numbers in the range of -128 to +127. There's the short, which stores numbers in the range of -32,768 to +32,767. And then there's the char. Char is not really a numeric data type. It stores letters or characters such as A or Z, but it stores them using the ASCII or numeric value of that character. If you're not familiar with the ASCII values, you might want to Google that term to give you an idea, but I'll just very briefly tell you that every character, letter, and symbol that you can find on the keyboard, as well as some non-printing characters such as tab and space, all have an underlying ASCII value that the computer uses to store or as a representation for that character, letter, or symbol. And the char data type uses that ASCII value to store a letter. That wraps up our discussion of the numeric data types. In the next lesson, we're going to talk about two important non-numeric data types, string and Boolean. After the numeric types, the most common data types you'll use in Java programming are string and Boolean. So let's go over those data types now. A string is 0 or more characters surrounded by double quotes. So for example, hello world is a string. Any characters surrounded in double quotes become a string. So if you put numbers inside double quotes, they become strings and not numbers such as integers or doubles. String is a class and not a built-in type. And that really has no meaning for you right now except the fact that there's lots of class methods that we can use. These methods can be used to do things like determine the length of a string, pull a substring out of a string, and many other types of string operations that you need to perform. Strings are limited primarily by your available memory. The practical number of characters you could store may be up to 2 billion, but nobody would create a string of that length. And in fact, nobody would, in their right mind anyway, would create a string that would use up all your available memory. So any size string you probably want to use, such as a sentence or a paragraph, would easily fit within the limit of a string's length. Strings can be combined with the plus or concatenation operator. We'll look at the details of performing that task in more detail later. The empty string, which is two double quotes butted together with no space in between, is a legal string object and is used quite often in Java programming. After the string, the next commonly used data type is the Boolean data type. A Boolean data type is either a true or false value. Boolean, unlike string, is a built-in data type, although there is a Boolean class that is used for some Boolean operations. Booleans are used in comparisons such as salary greater than 100,000, or in repetition, while the balance is less than 10,000, perform some task. And as we go through the course, you'll see lots of uses for Boolean data. That wraps up our discussion of the data types. So we've covered in the lesson previous, we talked about the integral and floating point data types. The two of those that are primary are the int for integer and double for floating point. And then we've also looked at the string data type and the Boolean data type. In the next lesson, we'll begin talking about how to store data using variables. Variables are used to store data in Java. Before we can begin using variables, we need to understand what they are and how to name them, because naming rules are very important in programming. So let's get started with this lesson. A variable is a name for a memory location. Memory locations are normally named using hexadecimal values, and we don't want to have to try to remember hexadecimal values. We won't be able to remember them. So instead we provide a name. A variable always has a type. When we create a variable, we always associate a type with it to tell the compiler what type of data can be stored in that variable. So that's another rule about variables. When we store data in a variable, we call that a value. That's not a technical term, but I'll talk constantly about a variable's value. And when I'm saying that, I'm talking about the piece of data that is stored in that variable. As far as the naming rules for variables go, the first rule is that a variable name must start with a letter. It cannot start with a symbol or a number. It has to be a letter. After the initial letter, a variable name may contain letters, numbers, and the underscore character. But notice that we don't include symbols like the $ or the %. So variable names are limited to a starting letter followed by any combination of letters, numbers, and the underscore character. Some examples of variable names are salary, name3, first underscore name, and last name, where the second part of the variable name is capitalized. We use that style called camel casing instead of underscores to make it a little bit easier to type the variable name. Some examples of bad variable names are 3name. That doesn't work because it starts with a number, and first underscore name. Finally, let's look at some other rules about variable names. There's no real limit to their length, although any name should be as short as possible and the name should be meaningful. In other words, if you're storing someone's first name in a variable, first name makes sense, or even F name makes sense, whereas F by itself, just the letter F, probably doesn't make sense because it's not easy to discern what that variable is trying to store just by the single letter F. There are situations where we use single letter variables, but not for meaningful data such as a name. And the last rule is variables should always begin with lowercase letters. That's because in Java, in this lesson we're going to learn how to declare variables in Java, but before we start, I want to show you how to set up a template file for your Java programs. That way you don't have to start from scratch every time you want to create a new program. So open a DOS window, move to your Documents folder, and then change to your Java subfolder inside Documents. And then type Notepad, and we're going to call this file template, although you can call it whatever you want to call it. The file name doesn't really matter. When we open it up, we want to create a skeleton Java program. So we're going to write public class template. We'll call it that. That'll be our class name, although we're going to change it every time we create a new program. Then move to the next line, type an open curly brace, indent on the next line, and type public static void main, string args inside parentheses like so. Move to the next line, type another open curly brace, skip a space, type a closing brace for the inner opening brace, and then another closing brace for the outer opening brace, and there's our template. We'll save that file. Now let's go through the process of how we'd actually create a new one. So I'm going to close that by exiting out. Now let's say I want to create a new program for my demonstration in this lesson. I'm going to call it variables. So I'm going to type Notepad template to open the template. I'm going to change the name to variables. That's going to be my program name and my class name. Notice I'm using a capital letter as we're supposed to do. Then I'm going to click File, Save As. Make sure I get in the right folder. So I've got to browse to find the Java folder. I just passed it. Change the name to variable. Or did I call it variables? I called it variables. So variables. And remember, they have to be Java files. So we're going to type variables.java. And then right here under Save as Type, I want to change that to all files, like so. So I click Save. And now I have the program file that I need to compile and run my program later on. So that's how we work with templates. Now let's look at how to declare variables. Move your cursor to inside the inner curly braces, indent a few spaces so that you're indented inside the string public static void main, and let's get started. To declare a variable in Java, we provide the data type followed by the variable name. So by writing int number semicolon, I'm declaring an integer variable named number. If I want to create a double variable, I do the very same thing. I type the data type followed by the name. I can do that with string. Notice that with string, you have to type a capital S. If you're coming from another language like C++, where the S in string is not capitalized, you may get a little confused at first. But always remember that the data type string in Java is capitalized. Let's do a char variable letter. and then a Boolean flag. So that's how you declare single variables in Java. Now an alternative would be to declare multiple variables of the same type on the same line. To do that, all I have to do is start with a data type, followed by a variable name, then type a comma, and then type another variable. And I can have as many on a line as I want. I'll just stick with 2 here, and I won't do every data type. We'll just do a couple here. String, we already have first names, so we'll do middle name, comma, last name. We'll do one more just to see how that works. Initials. So you can have multiple variables on the same line as long as you separate them by commas. So to review this very short lesson, to declare a variable, you provide the data type, followed by the variable name, followed by a semicolon, since all statements in Java have to end with a semicolon. If you want to have multiple variables of the same type declared on one line, just provide the data type once, followed by the first variable name, followed by a comma, and then however many other variable names as you need for that data type. So that about wraps up variable declaration. In my next lesson, we're going to talk about how to assign data to a variable, both in a declaration, which provides a third alternative to a variable declaration statement, and how to assign data to a variable in a separate statement. Once you've declared a set of variables, you're ready to assign data to those variables. And there's essentially 2 ways to do that. One way is to actually assign the value when you declare the variable. And you do that by just adding the assignment operator, which is the equal sign, followed by a value on the same line where the declaration is. So for example, where I had int number, I write int number equal sign 100, and I'm saying assign the value 100 to number at the same time that we're declaring the variable. We could also do that with rate, like so. If you can't or don't know the value of the variable when you declare it, then you can write an assignment statement later in the program. What we'll do is we'll move down below our last declaration. And so for example, I can assign a value to first name by writing an assignment statement. An assignment statement uses the assignment operator, the equal sign, followed by a value or an expression, I'll explain that in just a minute, to assign a value to the variable. So here I'm saying assign the value Jane to first name. I could reassign the value to number using an expression like so. So I can say assign the value 25 times 4 or 100 to number, which I've already done. So let's change that to 125 because it's kind of silly to reassign the same value just using an expression that yields the same result. So for some of our other variables, we can write letter equals A. Notice that when you assign a value to a char variable, you put it in single quotes rather than double quotes. That differentiates what we call a char literal A in single quotes from what I'm just going to write this out, I'll erase it in a minute, a string literal A would look like with double quotes. Char values are assigned using single quotes. And then for the flag variable, Boolean, we can write flag equals true to assign a true value for the variable flag. So that's how you assign values to variables using what are called assignment statements. Let me introduce another concept here real quick, the comment. Comments are parts of code that the compiler ignores that are strictly put into a program for the person reading the program to view. Comments can begin with a double slash mark like so, followed by the comment itself. Comments can either come at the end of a line like I've done there, or at the beginning of a line like that. Either way you write them, once the compiler sees the double slash, then it ignores the comment completely. There's one other way to write comments. If you want to comment out several lines of code at once, you can do that by using the old what's called C style, which got its name from the C language. Comments by writing a slash star at the beginning, followed by a star slash at the end. And by doing that, I've commented out everything from the beginning slash star to the ending star slash. So comments are important to make notes for people to read your program, because remember that when you write a program, it's just as important that people be able to read it as it is for the compiler to compile it and be able to run it. So comments can add lots of clarification into a program. So to review data assignment one more time, there are two ways to assign data to variables. One way is to do it in the declaration, like my example here where I write int number equals 100. And the other way to do it is in an assignment statement with these three examples right here, where we take the variable on the left-hand side of an assignment operator, the equal sign, and then write an expression or a literal to be the value of the variable on the left-hand side. In the next lesson, we'll actually do an exercise where we work with the Hello World program and use variables to change the phrasing from Hello World to other things. Let's end this chapter with an exercise. Let's modify the Hello World program and utilize some of the information we've learned about working with variables. So open a DOS prompt, navigate to your Java subdirectory, and let's open a new Java program. We'll call it Chapter 4 EX for Chapter 4 exercises.java. That will also be the name of our class. So we're going to write public class Chapter 4 EX, open brace, indent, public static void main, string, open close bracket args. Alternatively, you could have also opened your template file. I chose to show you one more time how to start a new program from scratch. I'll start using the template files in the next chapter. So, just as a refresher, to write hello world, we write system.out.println hello, comma, world, semicolon. Let's compile and run that program. So click File, Save. Navigate back to your DOS prompt. Type javac chapter 4 ex.java. Wait while it compiles. Then type Java chapter 4 ex. And we should see hello world. So now let's go back to the program. What I'd like to do first is modify who we say hello to rather than world. So what I want to do is I want to create a variable. We're going to move down, add a line, and we're going to write string name equals Bob. Then we want to get rid of world out of our string, so we're going to backspace over that, put a double quote following a space after the comma, then type a plus sign, and then type name. So what we're saying is we want to write to the system console hello, and then whatever value is stored in name, in this case Bob. So save that file, back to the DOS window, compile the program again, then run it with the Java command, and now it says hello Bob. I left out the exclamation point, but that's okay. Maybe we aren't all that excited to say hello to Bob. Go back to our program, and let's say we want to try another name. So we're going to write an assignment statement, and this time we'll say hello to Mary, and this time we will. We're happy to see Mary, so we'll put an exclamation point, but we don't want to put it in the name, because Mary, unless she's a really, really enthusiastic person, her name is not spelled Mary exclamation point. So we want the exclamation point to come outside of the string that stores name. What I'm going to do is I'm going to copy this command, put it back in here, and then what we'll do is we'll add another plus sign and put the exclamation point outside, like so, inside its own string. Click File, Save, go back to your DOS window, compile again, run again. Now we have hello Bob and hello Mary. Now maybe we want to modify the actual greeting. Maybe we're not always saying hello. Sometimes we need to say goodbye. So let's create a variable for that. Let's go back to our, put it at the top, string greeting. We'll start it out with hello. Let's take the comma out of that again. And now we're going to modify our print line statements to include the greeting, followed by a comma, space, followed by the name. So we don't need this other exclamation point or actually both of those plus signs. Do the same thing down below. And let's compile and run that and see. Compile, Java C, we run with Java, and we still have the same result. So now let's modify the output by changing the greeting to goodbye, like so. Then change, I'll tell you what, let's do. I copied an old version of the system out print line. Get the more recent version of that right here. Then save it. Back to our DOS window. Let's clear the screen. It's getting a little messy. Compile. And then run. Now let me juxtapose our output with the program itself. So you see how we can modify the Hello World program to include variables for both the name of the person we're greeting and the greeting itself, and we can change it to whatever we want it to be by using variables. That's the power of variables, is to be able to change the data that's stored in them so that we're not stuck with a literal string like hello or Bob. We can modify it any way we want to. In a future chapter, I'll show you how to prompt the user to enter this data so that the program doesn't have to store it initially. We can have the user enter it as the program runs.